So what I'm going to show you now is the analysis of authentication data using profiles, and in actual fact using profiles of profiles. But first let's look at what this actually gives us. So from the Los Alamos National Laboratories data set, we have a number of these authentication events. Now what I'm going to do is just run this search here to get the just the alerts here. I'm then going to prioritize those alerts so that, prioritize those the other way up, so we get the high value alerts at the top. Now, as we mentioned, the Los Alamos Labs set does contain some known attacks from a red team event, and so we do actually know who the real attackers were. And we're very pleased that without that knowledge in place, the profiler has successfully identified that user 66 was in fact the compromised user. So let's find out why. If we dig into this alert, what we can see is that user 66 attempted in this period a distinct number of authentications against average of 7.8 servers. So user 66 is trying to log on to 7.8 different servers on average over this time period. So what the rule that we've actually hit here is that we've got too many distinct authentication attempts for a regular user, which is why it's highly scored there. And what we've also done is, in the reason text, pulled out the full data and the baseline that we used to establish that. So you can see that they've logged into 7, we're just rounding there, which is significantly more, so more than 5 standard deviations from the median number of servers that a user attempts to log into. So we can see from this, the median's 1. So in this data set, most users tend to just log on to one workstation and then, they're done with most of their authentication. This user has tried to log on to quite a lot of them. And that's why that's been flagged up here as an alert for us to investigate. So if we have a look at how we would actually, derive that, then we'll just have a look at how that's set up in the Metron management UI. If I just look at that, that's coming from this auth sensor that we have up at the top here. Let's just have a look at the configuration for that. I'm going to look at the advanced view here because we are doing a little bit of advanced stuff with the profiler here. So, and I also want to show you a little bit of the Stellar configuration. So we have the parser, some very simple transformation there. The magic actually happens in the enrichment stage where we're interacting with the profiles and applying rules. So you can see here we've got this field that we're generating, the distinct auth attempts, which if you remember for user 66 was our 7.8 outcome there. What we're doing here is pulling back a window from the profile. So we're creating a profiler window here of 6 minutes. So that is very short. You wouldn't usually go with something that short. But what we're doing in this case is we're replaying the data at an accelerated rate because you know what? We didn't feel like sitting around for a month to wait for some results on this. So the demo's playing at accelerated rate. What we're then doing is we're grabbing back this profile, and this is the profile we've generated. It's distinct auth attempts by user. And we just use the user for the current event that's coming in to compare that, and then that window that we just built there. And what this gives us is the ability to then combine that, or to combine the mean cardinality across those profile units, because this profile will actually return us a number of different profile units for this window. So we're just averaging them out, which is why we got that 7.8. What we're then doing is looking at the baseline here. So we're doing another profile get call here on a similar window. We're actually looking at getting the global profile there rather than an individual user profile. And we're actually pulling a profile which is built from the distribution, so it's actually a stats distribution profile of the original user profile. So this allows us to then extract that baseline and look at both, pull out both the median and the standard deviation of that baseline, which we then use to determine whether or not something is actually an alert. Now, when we get, once we've assembled all of these pieces of information, you'll also notice we've got this additional piece here, which is the number of alerts by previous user. In an ordinary scenario, we would actually use this later to try and suppress some of the noise and reduce the number of excessive alerting for an individual user, or combine those alerts into one alert, for example. But in this instance, we frankly just wanted a little bit more data in our demo, so we turned some of that off. What we're then doing is pulling together all of that context that we have around the user to create a rule for the actual outcome here. So what we're saying here in this is alert statement is that we're taking out the previous alert. So this is that suppression piece. And we're also then using this, you're referring back to this distinct auth attempts alert, which we've built up from the context information that we acquired earlier. So we're looking at the distinct attempts, the standard deviation. This is just essentially a guard here. This is actually no longer necessary in recent versions. Rules will actually get even simpler, where we're looking at that simple calculation as to whether the difference from the median is greater than 5 standard deviations, and that will just tell us if this is a significant outlier or not. What we then do is we produce our formatting strings for these different score levels, which give us the ability to explain to the end analyst exactly what has gone on here, why this rule has been triggered, and therefore give them some sort of clue as to where they need to go to mitigate the threat. So to look at the way that those profiles are created, let's just have a look at the content of those profiles. And what we have here is the distinct auth attempts by user. You can see what we're doing is just because the profiler has access to all of the data streams, we just need to filter that down a little bit because we're only interested in looking at the authentication field here. So we're filtering that just down to authentication and getting rid of some dodgy data that's in that profile. What we then do is we run this profile for each user that appears in the set. So every message will group by essentially the user here. We then initialize our profile, and you can see here we're using the hyperloglog plus data structure, which allows us to estimate the unique or distinct number of items that the user has connected to. This 5 and 6, that lets you specify the precision of this, so it's a trade-off between essentially the amount of memory use and the accuracy of the measurement. So 5 and 6 generally works reasonably well for these kind of things, but that's a tuning parameter you may be interested in. Then what happens is for every message which goes through, we run this update loop. So what we're saying is that we're adding a field to the profile called total, and we're just going to add that hyperloglog entry to that. So what we're looking at here is taking each destination host from the data set and adding that into the hyperloglog set. What we then do is once we reach the end of a profile window, so every time you get a profile tick, in the case of our demo, it's every minute, but in a real system, it would usually be more like 5 or 15 minutes for the window. We output this total field. And so that's going to output my hyperloglog object, which is what I then refer back to in the previous enrichment rules. What we're also doing is specifying this triage piece here as well. What this will do is trigger the profiler to write out a message to Kafka, which will include this total count. So what we're able to do there is essentially treat the profiler as a sensor itself and loop back around into the Metron processing pipeline. So what we're sending there is actually the cardinality estimate. So what this is going to do is output a message which gives me the total number of unique destination IP addresses which each user has attempted to authenticate against in the time window for that profile. What we then do is we're actually profiling that profile. So you remember the baseline piece that we were looking at. We're using that baseline, or we're generating that baseline from this second profile here. And you'll see that this profile, we use the for each of global. Again, in a more complex implementation, this will more likely be based on something like a user group or some kind of peer group. Maybe it might be functional, or maybe it might be a departmental piece that we're using here. But here we're just going to lump all the users in as if they were, all roughly the same. But that becomes quite useful for peer group analysis. We're going to again filter down so that we're just looking at outputs from the profile, and we're looking to build this based on the outputs of this previous profile that we have here. In this instance, what we're doing is we're creating this stats object as the init pot. What that gives us is a t-digest, which is essentially a means of it's a data sketch which allows you to approximate the distribution of these bits of data. So that allows us to do a variety of the basic stats, like the standard deviation that we used in the enrichment output. So here again, for each profile that goes, each profile result that goes past, we're going to add this. We're going to add that total count field that we got from the triage statement into that profile, and then that's going to store that distribution out into HBase for us to retrieve later. So that's how we then create statistical distributions based on the outcome and result of the profiles, which then drive that baselining into the enrichment configuration, and ultimately through to our output here, which shows us the nice, well-reasoned explanation of why this alert is fired.